Jai Hind to all of you. My name is Dr. Ritish Kumar. I am going to give the lecture on the subject of antenna and wave propagation. The code of is BEC 603. The topic name is coordinate system and transformation. In this lecture, we will basically focus on the coordinate system and how we can transform one coordinate system to another coordinate system as well. So this is a university syllabus of the course, which categorized in 5 units. The first unit basically relate to coordinate system transformation. The second unit relates to electrostatic fields and magnetostatic field, and the third unit basically antenna fundamental definition, antenna design. Then the fifth unit is probably based on the wave propagations. So the whole syllabus consists the EMFT and the antenna wave propagation as well. So the recommended books I can refer. The first one is the SADICO, that is element of electromagnetics, and for the antenna theory we can refer the book C.A. Balanis, Antenna Theory and Design. The publisher is John and Billy. So basically here you can see the first unit is always be the coordinate system and transformation, because without understanding the coordinate system we cannot understand how the antenna radiates in the free space as well. So first we need to understand the coordinate system and its transformations. Let's begin the topic, the coordinate systems. So as we most probably there are three coordinate systems. The first one is the rectangular coordinate system, also we can say Cartesian coordinate system as well, and the second one is the cylindrical coordinate system, and the third one is the spherical coordinate system. These coordinate systems are the basic foundation of the antenna theory and design, or we can say the electromagnetic field theory as well. So the first one is start with the rectangular coordinate system or Cartesian coordinate system. As you can see here, this is a simple coordinate system that you have already aware about it. The x, y, z. This is a 3D system. We can say this is a x, y, z. So here this coordinate system has three plane. First one we can say the xy plane, this one is the xy plane, and this one is the yz plane, and this one is the xz plane. So this Cartesian coordinate system has three planes, xy plane, yz plane, and xz plane as well. So as we know, this coordinate system is basically represented by, if I say a point P which is represented by x, y, z in the Cartesian coordinate system, and it's we can say this one is the coordinates variable x, y, z, and we need to understand how much variation of x, y, and z. So the range of the variable here I represent the x is lie in between minus infinity to plus infinity. Similarly for y, minus infinity to plus infinity, and z from minus infinity to plus infinity as well. You can clearly see in the diagram, this one is the P point is represented by x, y, z. So x lie from minus infinity to plus infinity. By you can make it this one is dotted line as well. So you can say y is lie in between minus infinity to plus infinity. Similarly for z, minus infinity to plus z. This is a variable that we can represent in the rectangular coordinate system. If I say for the vector, for the vector in the Cartesian coordinate system, we can write either in this way or in this way. You all are aware about when we represented in a dark letter, then it can be a vector quantity. It must be a vector quantity, not it can be. So in other representation we can say ax A by and AZ. If I say in another representation of the vector A, you can see here, this one is AX cap, A by cap, AZ cap, where the AX cap, A by cap and AZ cap are the unit vectors, are the unit vectors along the direction of x, y and z respectively, right? So you can see here in the for the vector A, this ax representation, ax is represents the movement in the direction of x axis, and ay represents the movement in the direction of y axis, and az is represents the movement of in the z direction. So this is a vector representation of A in Cartesian coordinate system, right? So this is a basic terminology that we need to understand the Cartesian coordinate system. So second coordinate system is a cylindrical coordinate system. As we can see here, in the previous Cartesian coordinate system, the point is represented by x, y, z. Here the point is represented by rho phi z, where rho is the radius of the cylinder and phi is the azimuthal angle and z is the axis of the cylinder, right? So similarly, we need to find out the variation of rho, phi and z here. So you can see here in the diagram, this is, it looks like a cylinder kind of thing, cylinder kind of object, and in the cylinder kind of object there is some variable. So you can see this is a radius of, if I say this is point P, and how it can be represented in the cylindrical coordinate system, because this is the radius of the cylinder, this is the height of the cylinder, and this is the angle from the x-axis, the location of P from x-axis at angle is phi. So this one is the azimuthal angle, we can say this is the azimuthal angle, right? And it starts from the x-axis, right? So that's why this point is P is represented by rho, phi and z. So here you can see the variation of rho, or we can the range of the variable it starts from 0 to infinity. So you can say this is a 0 point, and the radius can be moved from up to infinity as well. So the rho lies in between 0 to infinity, and phi, you can see here, it can make a whole rotation, right? That's why its range starts from 0 to 2 pi as well. You can see here 0 to 2 pi, 0 to infinity, and z is similarly, in the case of previous Cartesian coordinate system, it lies in between minus infinity to plus infinity as well. So this is a point P is represented in cylindrical coordinate system. Here you can see, as we know, the dot product and cross product in the 12th class. So if the unit vector in the same same unit vector with dot product has the value is 1, and the different unit vectors with dot product has always the value is 0, right? In the cross we can say rho, phi and z. The cross of rho, phi would always be equal to az, phi z always be equal to a rho, and z rho is always equal to a phi. If I take the cross product of rho phi, means arrow a phi always be equal to az, phi a phi az always, the cross product of a phi and az always be equal to arrow, and az and arrow always be equal to, cross product always be equal to arrow, right. And here the arrow a phi and az are the unit vectors. Here you can see the direction of arrow always be in the radial direction of this radius. This is the direction of arrow, right. This is the direction of az, and the tangential component of the cylinder always be equal to a phi, right. So this is the unit vector in the cylindrical coordinate system, which is represented by arrow a phi and az here, and all are perpendicular to each other. So this is the cylindrical coordinate system. Now the transformation, or we can see that the relationship between x, y, z, or we can say the relationship between Cartesian coordinate system and cylindrical coordinate system, that is x, y, z and rho phi z. So here if I talk about the vector quantity, so this is a vector is represented in the cylindrical coordinate system. Here you can see this is the unit vector in cylindrical coordinate system. You can look at here, arrow a phi az is the magnitude in the particular direction, that is radial direction, azimuthal direction, and in the length direction az, right. Now the transformation of point in the x, y, z, you can clearly see here, this is a point P, the same point in the previous diagram, this is a point P, and I have taken in this figure a projection has been taken in the xy plane, and you can see this is a projection in the xy plane, and this point is when you combine this point from the origin, the angle the phi angle makes from x axis to up to this point, that is azimuthal angle is represented by phi, and you can see here this is a radius rho which is same as in the, similarly this is rho, right. This is a rho. So in the angle direction you can say the x always be equal to, the x is always equal to rho cos phi, and y equal to rho sin phi, right. Similarly x is equal to rho cos phi and y is equal to rho sin phi. As we know, in the direction of angle always be the cos the component of cos will lie, and in the opposite direction of the angle the sine component always be lie, right. So x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. This is the transformation of the variable from cylindrical coordinate system to the Cartesian coordinate system, right. So and from these transformation we can find the angle of phi. If I take the ratio of y by x, then we have tan phi is equal to, from these 2 points we have tan phi is equal to y by x, and phi is equal to tan inverse y by x. This is the azimuthal angle formula here we have, and if I take the square root of these, means x square plus y square is equal to rho square, and rho is equal to square root of x square plus y square. This is the radius of the cylinder in terms of Cartesian coordinate system, right. And z is always be equal to the z, which is similar into the Cartesian coordinate system. So this is the point transformation of the point transformation of cylindrical coordinate system into the Cartesian coordinate system, and we can also say that this is a relationship between the Cartesian coordinate system and cylindrical coordinate system when we talk about the point variable. Now, the vector transformation of cylindrical coordinate system into the Cartesian coordinate system. So, you can see this is a transformation matrix that I have written over here. So, you know the value of a rho, a phi, a z, which is in the cylindrical coordinate system, and you find this vector quantity into the Cartesian coordinate system. Then you need to take this matrix transformation. This is matrix you need to understand. So, as I know, x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z, right? So, how you can remember this matrix from that transform the cylindrical coordinate system into the Cartesian coordinate system. So, you can see first this is a x and a rho. So, the first element of this matrix should be differentiated by rho. Mean if you take the differentiation of this dx with respect to rho, then you will get cos phi, right? Then this cos phi should be differentiated with respect to the phi, because ax a phi. So, you need to take the differentiation with respect to phi. So, this cos phi cos has the differentiation. If you take the differentiation of this cos, then you will get minus sin phi, and if the third term ax az means you have to take the differentiation with respect to z, but in this there is no z, that's why the value should always be come 0, right? Similarly, if you take if you consider the y, here the y component rho sin phi, first you have to take the differentiation with respect to rho, then you will get sin phi, then sin phi you need to take the differentiation again, then sin sin converts into cos phi, and there is no component z, that's why is equal to 0. And if you take the z, here there is no rho component in the z, there is no phi component in the z, only the z component in the is there, that's why the last term should always be equal to 1. This is the way how you can remember this transformation matrix that converts from Cartesian converts from cylindrical coordinate system to the spherical coordinate system, right? If you and vice versa, just to do the if you want to convert the Cartesian coordinate system into the cylindrical coordinate system, then only the thing you have to change the rows. Row in this matrix you can change the rows with column and vice versa. You can see row means this column converts into row cos phi sin phi 0 minus sin phi cos phi 0 0 0 1. That is the way you can remember the transformation matrix, right? Without using this transformation matrix, you cannot able to convert the vector from cylindrical coordinate system into the spherical Cartesian and vice versa as well. The next coordinate system is a spherical coordinate system. This is the you can see this is a point P, and this is a unit vector representation of the point in the spherical coordinate system. Here here the point is represented by r, theta and phi. R is the radius of the sphere, r is the radius of a sphere, theta is the elevation angle and phi is the azimuthal angle. Right, phi is the azimuthal angle, r is the radius of the sphere, and theta is the elevation angle. So phi is the same as in the previous case in the cylindrical coordinate system, and theta is making the angle from the z axis, right. This is the azimuthal angle which starts from the z axis towards the point P, and this is the unit vector, this is radial direction, and this is the unit vector of AR. This one is tangential component A phi, and this one is A theta, right. And the range of the variable that you need to understand, r should lie from 0 to infinity, right. And theta you can see here, theta can vary from 0 to pi. Otherwise you can say minus pi by 2 to plus pi by 2, or 0 to pi, and phi makes whole circle, that's why it lies from 0 to 2 pi, right. So this is the range of the variable that you need to understand in the spherical coordinate system, right. So next is the similarly that we can see here, the same vector component, the same unit vector component, the dot product of the same unit vector has a value equal to 1, and different unit vector has a value equal to 0. And cross product similarly as we have in the previous cylindrical coordinate system, here you can make it r theta and phi. Make it the cross product of these unit vector AR A theta, you will get A phi. A theta A phi, you will get AR, and A phi cross AR, you will get A theta, right. This is similar way you can write here, and this is a, and here the AR, A theta and A phi are the unit vectors in the spherical coordinate system, and all are perpendicular to each other. The relationship between spherical coordinate system, cylindrical coordinate system and Cartesian coordinate system, that we can see here. This is the point P in the spherical coordinate system, and this P point you can have in the Cartesian P x y z, r theta phi in the spherical coordinate system, and rho phi z in the cylindrical coordinate system. So this is the vector that we have in the spherical coordinate system. But how you can understand, because here I am using the unit vector AR, A theta and A phi, that's why we can say this vector is given in the spherical coordinate system. The point transformation of r theta phi into the x y z. So here the relationship between x y z and r theta phi, as you can see in the figure, this P point has the distance r from this origin point, this, and this theta angle makes from the z axis, that's why this r has two components, r cos theta which is into the direction of z, and r sin theta which lies in the x biplane, right, x biplane. So rho is equal to, you can say, r sin theta, right, and this r sin theta has two component, r sin theta if you say in the x direction, then x is equal to r sin theta cos phi, this is rho cos phi you can say, and in the direction rho sin phi, and rho is equal to r sin theta sin phi, and z is equal to r cos theta. I hope this point is clear to all of you, right. By using these three variables, you will get the r is equal to square root of x square plus y square plus z square, and theta is equal to tan inverse x square plus y square upon z, and this you can also write rho y z, and phi is equal to tan inverse y by x. So these are the relation between x y z, rho phi z, and r theta phi. We can say these are the relationship in between spherical coordinate system, cylindrical coordinate system, and Cartesian coordinate system as well. So so in this study, in this topic, we mainly uh, we we have focused on the Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. I hope these all the three coordinate system are clear to all of you. And the last one is the vector transformation. So similarly, we have the vector transformation matrix is need to understand how we can remember. So as far as we know, x is equal to similarly r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta, right? So similarly, that we have in the cylindrical coordinate system, the AR means in the AR AX, you need to take the differentiation with respect to r. That's why first component is the sin theta cos phi. Second would be you need to take means you have to take the differentiation with respect to theta, means sin theta cos phi, and uh, mean the second is sin theta sin phi and cos theta. Similarly, we have the last we can say the r cos theta, means you have to take the differentiation. I hope this is the transformation from rectangular coordinate system into the spherical coordinate system. But here I am talking about the transformation of uh, a spherical coordinate system into the rectangular coordinate system. So first you need to look over this transformation matrix here, right? The first one you need to take the differentiation with respect to the r means sin, this should always be equal to 1 sin theta cos phi. The second one should be differentiated with respect to theta. This sin theta would convert into cos theta cos phi, and the third one is differentiated with respect to a phi. This cos phi would become minus sin phi, right? Similarly, r sin theta sin phi means first you have to take the differentiation with respect to r sin theta sin phi, then again theta, you have to take the differentiator with respect to theta, sin theta cos theta sin phi, then sin phi would become cos phi. Similarly, for the z case, with respect to r cos theta again minus sin theta, and there is no component of the phi, that's why it would become 0. And this is the way you can remember, this is the method you can remember this transformation matrix. And if you want to convert this Cartesian coordinate system into the spherical coordinate system, just change the rows into the columns and vice versa. So I hope this transform here I have covered the topic of point transformation and vector transformation in rectangular coordinate systems, cylindrical coordinate system, and spherical coordinate systems. I hope these all the coordinate system are clear to all of you. Thank you.